warm good morning, my dear students. Welcome to this chemistry digital class.
As we have studied that biomolecule, the origin of biomolecule is somewhere. It is the cell, basic unit of body. Inside that, nucleus, cytoplasm, and plasma membrane is there. If you will tell about plasma membrane, the plasma membrane is composed of protein, and basic unit of protein is amino acid. Similar way, cell wall is composed of cellulose, and cellulose is made up of sugar and sugar component, that is carbohydrate. Okay, and the nucleus have supermolecular complexes, chromosomes. Chromosome is made up of DNA, and DNA is made of nucleotides. Okay, after this, if we will talk about meaning, the biomolecule meaning is it is living. Bio mean living organism, molecule mean combination of elements. So these are the small organic molecules which bound together to create large organic molecules called macromolecules or biomolecules. There are 4 classes of macromolecules: carbohydrate, protein. We have studied carbohydrate, protein, lipids, and nucleic acid. So one by one we will study in detail. So already we have started carbohydrate. So before going to start carbohydrate, let's understand first the classification of carbohydrate. So basically biomolecule are classified into inorganic and organic. And inorganic biomolecule, if we will tell inorganic biomolecule, the inorganic biomolecule are water and minerals, and organic biomolecule are glucosides, which is monosaccharide, polysaccharide, lipids, which is fatty acids, proteins, which is amino acid, and nucleic acid, which is made up of nucleotide. So basically, if you will tell biomolecule have 2 types: microbiomolecules and macrobiomolecules. Microbiomolecules are small size but low molecular weight, between 18 to 800 Dalton. These are minerals, gases, water, sugar, amino acid, nucleotide, etc. Whereas if we talk macromolecules, these are large size, high molecular weight, about 10,000 Daltons, found in the acid insoluble pools. So these biomolecules we are talking: carbohydrate, lipid, protein, and nucleic acid. Okay. So after this, we have started our carbohydrate, which is glucose, and it is called instant energy source of our body also. So basically we studied that there are 3 types of carbohydrate: monosaccharide, oligosaccharide, polysaccharide. Monosaccharide are the basic unit of carbohydrate, which cannot be hydrolyzed into smaller unit. It is based on the number of carbon atom. It is based on the type of functional group. Whereas oligosaccharide, they can be further hydrolyzed: disaccharide, trisaccharide, tetrasaccharide as example. Polysaccharide are non-crystalline, non-soluble in water. It is tasteless on hydrolysis, which gives molecular mass of a mole of monosaccharide. Starch and cellulose are the basic examples. Students, the basic unit of carbohydrate, the first monosaccharide in carbohydrate is glucose. It is aldohexose. It can occur freely as well as in combined form in the nature. It is present in sweet, fruit, and honey. It is also present in large quantity of ripe grapes. It is known as grapes sugar or dextrose. If we will talk about preparation of glucose, the glucose can be prepared from sucrose, or it can be prepared from starch. It can prepare from sucrose by hydrolysis. Then C12H22O11 will break down into C6H12O6 and C6H12O6, which is glucose can be easily obtained in laboratory by the hydrolysis of alcoholic solution of cane sugar. Sucrose with dilute HCl or H2SO4 at 50 degrees Celsius will give glucose and fructose. And when we are preparing it from starch on large scale, glucose can be prepared by starch by hydrolyzing the starch or cellulose, in which formula is C6H12 H10O5, and it will give us, on hydrolyzing at this temperature, 6,6H12O6. Then most important structure of glucose, as glucose is an aldohexose, it means that aldehyde group is there, which is consist of carbon atom and an aldehyde group. It is the monomer of many of the large carbohydrates such as starch, cellulose. It is the most abundant organic compound on the earth and is used in immediate source of energy, dear students. So if we will talk about structure evidence of glucose, basically 6 carbon is there, 4 carbon is here, and 1 carbon is there. So it means that total 6 carbons. So you can see here, this is 1 carbon, there are 4 carbon, there is 1 carbon. So 1, 4, 5 plus 1, 6. In which the first carbon have aldehyde group, last carbon have primary alcoholic group. And in between which whatever carbon is there, they have secondary alcohol group. Secondary alcohol group you know very well. One side R, C, OH will be there. Okay. If molecular formula we will say it is C6H12O6, and there is presence of a straight chain. If we will take straight chain, it will come from N-hexane, or in the presence of HI, this glucose is giving us N-hexane. So dear students, if we will tell about configuration of glucose, configuration, you know, it is amyl feature which gave the exact special arrangement of different OH group in glucose. After studying many other properties, its configuration is correctly represented in 1. So gluconic acid is represented as 2 and saccharic acid is in 3. So what is there? Dextroglucose. This is the exact configuration of glucose. Mean the structure of glucose is like this way. There are 6 rings in a row. 1, 2, 3, 4. Here is also carbon, 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 carbon. So you can see first carbon is attached with aldehyde group. Rest, second carbon have right hand side OH. Third carbon has left hand side OH. Fourth and fifth carbon have right side OH. Once again, first carbon is aldehyde, second carbon have hydroxide group, secondary alcohol group on the right hand side. If you will take it right hand side, this is left hand side. Third have left hand side, and fourth and fifth again have right hand side. Sixth have right hand side with CH2. This is primary alcohol because 2 hydrogen is there. Okay, this is called dextroglucose. Whereas same way gluconic acid, difference is COH. In place of aldehyde there is carboxylic acid, rest is same. Whereas saccharic, both 1 and 6 have carboxylic acid. This is saccharic acid. So this is the difference between glucose, gluconic and saccharic acid. Glucose is named as dextroglucose, in which D represent the configuration, whereas plus represent the dextrorotatory. Now D and L has no relation with the optical activity of the compound. So this D and L notation mean D and L before the name of any compound commonly indicate the relative configuration of particular stereoisomers. Mean अगर यहाँ D होगा या L होगा तो that represent the particular configuration, particular stereoisomerism. For example, glyceraldehyde contain one asymmetrical carbon atom and exist in 2 anisomeric form, which can be like this way, dextro and levo. In case of dextro, the OH will be right hand side, second OH will be right hand side, whereas in levo there will be left hand side. It is like if I will use this pen, this side left hand side, the tip is on left hand side and tail is on right hand side. If I will move it like this way in a special arrangement, now you can see the tip is in right hand side and tail is toward left hand side. So in this way, when tip is toward this side, tip side is hydroxide, tip side is hydroxide. If tip is toward right hand side, then it is called dextro. Then it is dextro. Whereas on the other hand side, when we will move this स्पेशल अरेंजमेंट, जो ग्लूकोज का स्ट्रक्चर है वो लाइट की प्रेजेंस में ऐसा घूमता है गोल. सो इफ इट इज टिप इज टुवर्ड राइट हैंड साइड, नाउ सपोज दिस साइड लेफ्ट हैंड साइड, दैट्स व्हाई इट इज कॉल्ड एल. तो कीप इट लेफ्ट L. If OH is left side, then it is L rotatory. If OH is right hand side, then it is dextro rotatory. Okay. Similar way, when we will talk about the cyclic arrangement. So if we will talk about the cyclic structure of glucose, the cyclic structure of glucose is somewhere it is like this, Haworth structure. This is called Haworth structure. Now if you will see dextroglucopyranose, it is same. Carbon number 1, carbon number 2, carbon number 3, 4, 5 and 6. This is sixth one. So you know very well, carbon number 1 have CHO. So CHOH, if you will tell, and second has right side OH, then third have OH left side, fourth have OH down, fifth have CH2OH on the top. Okay, so take screenshot and try to practice this structure. Now one more video I am going to share, that is animated video related to structure of glucose. So it will, maybe from that video it will be clear that the structure of glucose. So practice structure of glucose. And Once again, before going to finish, please, tomorrow is the last day to submit your assignment, and you all must complete that assignment. So thank you. Thanks a lot. Have a nice day.
Glucose C6H12O6. Glucose occurs in nature in free state as well as in combined state. In free state, it occurs in sweet fruits and honey. Ripe grapes contain up to 20% glucose. In combined state, glucose is present in disaccharides and polysaccharides. Maltose and starch on hydrolysis yield only glucose. The methods of preparation of glucose are following. By hydrolysis of cane sugar. It can be prepared by hydrolysis of cane sugar in the presence of alcohol using dilute hydrochloric acid. Glucose and fructose are formed in equal amounts. Glucose is less soluble in ethyl alcohol than fructose, so it crystallizes out. By hydrolysis of starch. On commercial scale, it is prepared by hydrolysis of starch by boiling it with dilute sulfuric acid at 393 Kelvin under a pressure of 2 to 3 bar. Cyclic structure of glucose. Some evidence suggests that the open chain structure of D-glucose exists primarily in equilibrium with two cyclic forms. Many reactions indicate the absence of CHO group. It is found to exist in two different crystalline forms, which are named as alpha and beta. The alpha form of glucose is obtained by crystallization from a concentrated solution of glucose at 303 Kelvin, while the beta form is obtained by crystallization from hot and saturated aqueous solution at 373 Kelvin. It exhibits mutarotation. The change in specific rotation of an optically active compound to an equilibrium value is known as mutarotation. These observations are attributed to the fact that sugars generally exist in the form of cyclic hemiacetal or hemiketal structures, and only a very small number of molecules exist in open chain structure.